Hello guys, I'm really glad to see you back again. Today, we embark on a journey through peaks and valleys as we explore critical points and monotony in calculus. First of all, let us consider the function f of x equal x squared plus 1. Now, if we analyze the tangent line that passes through the point 0, f of 0, we notice that the tangent line is completely flat, and this only happens with lines when the slope of such a line is equal to 0. However, we know that the slope of the tangent line is equal to f prime of the point, in this case, f prime of 0. So, f prime of 0 is equal to 0. Now, if we analyze what happens with the tangent line before the point 0, f of 0, we notice that the tangent line is decreasing. Therefore, we can say that f prime at those values is negative. But if we analyze what happens right after the point 0, f of 0 with the tangent line, we notice that the tangent line is increasing. Therefore, we can say that f prime at those values is positive. The previous analysis leads us to the following definition and results. The first one establishes that a point C, f of C, is said to be a critical point if and only if f prime of C is equal to 0 or it doesn't exist. As well, we say that a function f is increasing in an interval ab if and only if f prime of x is greater than 0 for all values of x in the interval ab. And a function f is said to be decreasing in an interval ab if and only if f prime of x is less than 0 for all values of x in the interval ab. Consider the function f of x equals 2x cubed minus 3x squared minus 12x plus 5. Then its derivative is 6x squared minus 6x minus 12, which can be factored as 6 times x plus 1 times x minus 2. Therefore, f prime of x is equal to 0 if and only if x is equal to -1 or x is equal to 2. Thus, we can say that the critical points of f of x are x equal -1 and x equals 2. Now, we are going to consider the following table, which is made of the intervals minus infinity, -1, -1 and 2 to infinity. And we are going to take a value between those intervals and we're going to plug it in the function f prime. And depending of the sign of the result, we are going to establish if the function is either increasing or decreasing. Now, in the first interval, we're going to take the value of x equals -2 and we're going to plug it in f prime. If we do so, we get the result 24. And as 24 is positive, we can say that the function f of x is increasing in the interval minus infinity minus 1. Finally, if we take the value of x equals 3 in the interval to infinity and we plug it in the function f prime of x, we get as a result 24. And as 24 is positive, we can say that the function is increasing in such an interval. Try to find the intervals of monotony of the following functions. Be careful with your calculations so you can avoid causing any critical damage to which you can't go back.